And welcome students. So today's video is all about pH, pKa, Ka, Kb, pKw, Kw. What am I saying, right? So many of you have these doubts. What is this pKa or pKb or pH, or what is the difference between all these things, or are they all same? So no, they're not exactly same, but what's the difference? So we are going to talk about that today. So if I start with pH, so as we are studying in 10th grade, or if you have already studied in 10th grade, if you're a grade 11 student, so you must have studied that pH is the negative logarithm of H plus ion concentrations or H3O plus ion concentration. So I can write like minus log of H plus concentration. Now when I write a square bracket H plus, it means concentration of hydrogen ions, or you can also write it as H3O plus when you have added an acid with water. So it's an aqueous solution. So of course there will be H3O plus, which is hydronium. Concentration of H3O plus ions. This is also called as active mass. Now why active mass? Active mass is nothing but the concentration, which you can calculate as N upon V, which is kind of molarity, right? Moles upon volume of the solution. Hello students. So whenever I talk about, or we talk about acids, bases and salts, the term that comes to my mind is pH. Now what pH actually does? So it tells you about the strength of the acid or the base. Now do the salts have pH or not? Let us understand that also. Before that, when I talk about pH, what does it mean? It means power of hydrogen. Now what is this power of hydrogen? एसिड और बेस की जब आप बात करते हो तो एसिड कितना स्ट्रॉन्ग है या बेस कितना स्ट्रॉन्ग है या एसिड कितना वीक है, ये सब हमको पीएच की नॉलेज से पता चलता है. अब एसिड स्ट्रॉन्ग कब होगा और वीक कब होगा, उससे पहले हमें एसिड की पूरी तरह से डेफिनेशन पता होनी चाहिए. दैट मीन्स वी नीड टू नो all definitions of acids as well as bases. So there were different scientists working upon acid bases and they came up with different definitions. We'll start with Arminius definition first of all. So Arminius said that any substance, so according to Arminius, we are starting with that. Any substance when dissolved in water, if it releases hydronium ions, it is said to be an acid. मतलब जैसे मैंने एक HCl की एक सब्सटेंस है मेरा जिसको मैं वाटर में डिसॉल्व कर रही हूँ, so it should release hydronium ion H3O plus and the respective will be conjugate base. What is this conjugate base or conjugate acid? That is also important that we have to discuss. Now H3O plus इसने बना दिया, so this is an acid. Similarly, a substance when dissolved in water, when it releases OH minus ions, it is said to be a base. So if I have NaOH and I have dissolved it in water, it is going to give me Na plus ions and OH minus ions. So when I write ions, because they are being produced in an aqueous solution, I'll write aqueous in front of them. Here as well as here. Even here I should write aqueous because they are also solutions. Okay. So this, because it is releasing OH minus, so this is my base according to Arminius definition. And the counterpart, the plus part over here becomes the conjugate acid. What is this conjugate acid? And this is conjugate base. First I'll talk about all the acids and bases, then I'll talk about the conjugate bases also. Okay, so this was your first definition. Now there were two other scientists, one named Johannes Nicolas Bronston and the other one was Martin Lowry. So together their names they are named as Bronston Lowry, and they gave a definition that when a substance gives a proton or donates a proton, it is said to be an acid. So what does that mean? Can any substance give out a proton? No, not really, right? So giving out a proton means giving out an H plus, because acids do what? Acids actually release H plus. If you have ever observed, all the acids, they release H plus, and proton over here refers to H plus again. So if I write H plus, this is my proton, because hydrogen has one electron, one proton. Now one electron is removed, it will become H plus, and that is nothing but it contains only a proton, right? So this is an H plus, which is also referred to as proton. So all the acids that will release H plus, which is proton. So the bases over here, according to this definition, will be the substances which accept a proton. Base will be a substance or compound that accepts a proton. Now there's one more definition. We'll also talk about the examples. Now the last definition, which was given by the scientist Lewis. So according to Lewis, an acid and a base, they are determined by the loss or gain of electrons, you can say. So an acid is a substance or a compound that accepts electrons and base, on the other hand, becomes the electron donor compound. Okay, so if an acid is giving out H plus, that means it becomes electron deficit, right? Electron deficit or electron deficient. So if it is electron deficient, of course, what will it do? It will accept electron. And a base, because it accepts H plus, that means it already has a good amount of electrons. So because it has more amount of electrons, it will donate electrons. We will see the examples over here. Now do remember all these definitions before checking any acid or any base or any compound. For example, if I have NH3, this most of you might be knowing already also. Like, I don't see any OH over here, right? Like all the examples of acids, they contain hydrogens, and all the bases example, they contain OH minus. But I don't see any OH minus. So what should I call it? An acid? Well, no. Because when I look at the structure of NH3, which is ammonia, it has 3 hydrogens and 1 lone pair of electron. It doesn't look like this. In 3D, it's a pyramidal shape, but on paper, I've shown it like this. Or on board, I've shown it like this. Okay, so this lone pair, because it is an extra pair of electrons, if there is an H plus in the vicinity or close by NH3, what is it going to do is, जैसे इसकी surrounding में अगर H plus है और इसके पास extra electrons है, so it is going to donate this extra electron pair to that H plus which does not have any electron and make a bond with it. And because it is donating electrons, so it has to be basic in nature. Now when it donates electrons, it forms a covalent coordinate bond and it develops a plus charge. It has a 3 valency and if it exceeds that valency to form 4 bonds, it gains a plus charge. We will talk about structures in another video. Okay, so here it is NH4 plus. Now this NH4 plus dissolved in water forms NH4OH, which is your ammonium hydroxide, and there you have OH also with the formula. So this becomes a proper base, right? It is going to follow all 3 definitions now. So it has donated electrons, it has accepted a proton, it also can release OH minus ions, right? So that's how NH3 or ammonia is a base. It is a weak base. Now why a compound is termed as weak or strong? That is also something we have to study now. Now when these acids break or they give out H plus, they form conjugate bases. Now what are these conjugate bases? For example, if I have HCl, which is giving out H plus and Cl minus, or if I have it in H2O that is dissolved in water, it is going to form H3O plus and Cl minus. Okay, this is hydronium ion. How to form hydronium ion? Okay, for that also I'll show you. This is water with 2 lone pairs. Now if it has H plus ions in the vicinity or dissolved in it, what is it going to do is, hydrogen has no electrons, so there cannot be a bond with it. It's lone, or you can say it's free, H plus free proton. When this lone pair is donated to H plus or the water is accepting H plus, it is forming with a plus charge. Okay, again oxygen, because it has 2, its valency is 2, so it should form 2 bonds, but over here it is forming 3 bonds, that is 1 bond more than its valency, so it will get a positive charge. I should show it like this. Okay, that's your hydronium ion. This one is the coordinate covalent bond. Alright. Now when I talk about the conjugate base, H plus रिमूव हो गया, यानी ये एसिड है, बट जो नेगेटिव पार्ट है वो है कॉन्जुगेट बेस. Similarly, if I have a base dissolved in water, it is going to form Na plus and OH minus. So this positive is going to be called as conjugate acid. Now they also have the similar definitions of acids and bases. Now firstly, when I talk about conjugate base is the species formed after protonation of an acid. तो प्रोटोनेशन हो चुका है एसिड का, उस मतलब प्रोटॉन उसने दे दिया है, H प्लस दे दिया है, उसके बाद जो बचता है द नेगेटिव पार्ट, दैट इज कॉन्जुगेट बेस. अब आप देख सकते हैं जो नेगेटिव पार्ट है, व्हाट इज इट गोइंग टू डू? इफ इट इज गोइंग टू एक्सेप्ट दिस H प्लस बैक, तो उसका डेफिनेशन ब्रॉन्स्टन लॉरेट के हिसाब से क्या हो जाएगा? बेस का डेफिनेशन, विच इज अ सब्सटेंस और कंपाउंड दैट accepts a proton, right? Now one more thing, it has electron in excess. Negative मतलब कि ज्यादा इलेक्ट्रॉन है, तो वो इलेक्ट्रॉन डोनेट कर सकता है. अगेन Lewis definition is also followed, है ना? So the one that accepts proton is conjugate base, and conjugate base बोलते हैं उसका काउंटर जो पार्ट होता है. Similarly यहाँ पे conjugate acid Na plus होगा because it is electron deficit, so it is going to accept electrons, and it is not going to accept H plus, but it can accept OH minus. Okay, so Bronston-Lowry भी satisfy हो गया, Lewis भी satisfy हो गया. Okay, now one more equation that is important. Whenever you have an acid and base reacting together, they form conjugate base and conjugate acid. How? Now over here you can consider one of the part as acid, the other one as base. Now which one to consider a base and acid? जो भी H plus ट्रांसफर करेगा दूसरे स्पीशीज को, or the compound that gives out proton to the other one is the acid and the one accepting is the base. Okay, now we can make conjugate acid and conjugate base in the first case. HBr जो है अपना प्रोटॉन इसको दे देगा, तो क्या बनेगा, H2O अगर प्रोटॉन एक्सेप्ट कर ले so it will become H3O plus and Br क्या हो जाएगा, अब उसने H plus दे दिया है तो बचा क्या, Br minus. Okay, so Br minus is the conjugate base and H3O plus is the conjugate acid. और if I look back at it तो क्या होगा, जो ये conjugate base है उसका acid ये है HBr, क्योंकि इसने प्रोटॉन दे दिया है. ओके, और जो प्रोटॉन दे देता है फिर जो बचता है Br minus, that will be your conjugate base. So this is acid. Over here water is acting as a base. This is my conjugate what, acid, and this is conjugate base. Similarly, in the next reaction, now nitrous acid and water. Now here again I will get ये HNO2 जो है, अभी तक आप समझ ही चुके होंगे क्या बनेगा यहाँ पे. Now in the product side NO2 will be devoid of H plus, so it will be NO2 minus and H3O plus. So again this is conjugate base, this is conjugate acid. Here again it is acting as base. Acting as base क्योंकि it is taking the proton. Water is taking the proton. Now OH minus NH4 plus. These already look like conjugate acid and conjugate base. This containing a plus charge becomes conjugate acid. This with a negative charge conjugate base. Now how well are they acid or base? Now over here there is an extra H plus. अब वो extra H plus जो है अगर वो ये accept कर ले, OH minus accept कर ले, so it will be a good base. बेसिस का काम क्या है, H plus एक्सेप्ट करना, और एसिड का काम है H plus रिलीज करना. सो अगेन कॉन्जुगेट तो है ही वो, लेकिन एसिड की भी प्रॉपर्टी दिखा रहा है. कॉन्जुगेट मतलब वो किसी बेस का पार्ट है, बट कॉन्जुगेट एसिड कहा है उसे, तो एसिड की भी प्रॉपर्टी दिखाएगा. एसिड की प्रॉपर्टी क्या है, H plus देना. सो इट इज गोइंग टू, because this is conjugate acid, this is conjugate base, so this is going to accept proton and this is going to transfer a proton. This is going to give out a proton. अब ये अगर H plus हटा दे, पहले इसके पास जैसे ये है N H H H and one more H with a plus charge. अब एक H अगर ये हटा दे तो इसका प्लस चार्ज भी न्यूट्रलाइज हो जाएगा. It will come back to its original valency which is 3 and it will only be forming 3 bonds. तो NH3 हो जाएगा with a lone pair plus OH minus ने H plus ले लिया, तो OH minus और H plus क्या हो जाएगा, H2O. एक OH minus है और एक H plus है, तो ये टोटल क्या हो जाएगा, H2O. So you can copy down all the conjugate bases, conjugate acid. Conjugate base or conjugate acid are nothing but the departed species and they will exactly act like acid or base, but they are the counterpart of the acid or the base. Okay, so this becomes a reaction of acid plus base giving conjugate acid and conjugate base. That's how you have to identify conjugate acids and bases. Now I'll give you some more questions or just a few compounds. You have to understand which will be the conjugate acid or conjugate base of that particular compound. Now I have some examples over here for you. You have to identify the conjugate acids and bases of these compounds. Like you have H2PO4 minus over here. Now this is already minus and you must be now identifying कि जितने negative हो जाते हैं वो सारे conjugate bases होते हैं. ओके, तो अगर ये कॉन्जुगेट बेस है तो कॉन्जुगेट एसिड क्या होगा, जिसके पास ऑलरेडी H होगा, ये H प्लस रिलीज होने के बाद मिला है, तो कॉन्जुगेट एसिड क्या होगा, जिसने H प्लस ले लिया होगा वो कॉन्जुगेट एसिड है. ठीक है, जिसके पास ऑलरेडी H प्लस हो, क्योंकि एसिड्स क्या करते हैं, H प्लस रिलीज करते हैं. तो यहाँ पे कॉन्जुगेट एसिड यहाँ पे होना चाहिए जिसके पास ऑलरेडी H प्लस हो. अगर मैं इसमें H ऐड करूं तो ये क्या हो जाएगा, H3PO4. वाई H3PO4 बिकॉज इसमें H2 है, तो ये कॉन्जुगेट बेस है, क्योंकि ये नेगेटिव है तो ये बेस है, कॉन्जुगेट बेस। तो इसका एसिड कौन होगा, इसका एसिड कौन होगा, H3PO4। अब इसका कॉन्जुगेट बेस कैसे बनेगा, इसका भी कॉन्जुगेट बेस अगर हमें बनाना है HPO4 2-। अब ऐसे समझो, जो बेसिस होते हैं दे हैव एक्स्ट्रा इलेक्ट्रॉन्स, ओके, नाउ दे हैव एक्स्ट्रा इलेक्ट्रॉन्स। तो यहाँ पे माइनस था, यहाँ पे 2- है, दैट मीन्स 2 इलेक्ट्रॉन्स। इसके पास एक्स्ट्रा इलेक्ट्रॉन्स है, ये डोनेट कर सकता है इलेक्ट्रॉन, एंड इसके पास एक H भी कम है, सो दिस इज बेस, ओके, सो दिस बिकम्स कॉन्जुगेट बेस। अभी यहाँ पे HSO3-, अगेन हाइड्रोजन रिमूव कर दो, यू विल गेट द कॉन्जुगेट बेस, एंड हाइड्रोजन ऐड कर दो, यू विल गेट द प्रॉपर एसिड, ठीक है। सो फॉर दिस पर्टिकुलर आयन दे विल बी कॉल्ड एज कॉन्जुगेट एसिड एंड कॉन्जुगेट बेस। फॉर दैट एसिड दिस विल बी कॉल्ड एज कॉन्जुगेट बेस। जैसे ये एसिड है, इसके लिए ये कॉन्जुगेट बेस है, बट इस बेस के लिए ये कॉन्जुगेट एसिड है, ओके। सिमिलरली HSO3-, तो यहाँ पे एक H+ हो जाना चाहिए यहाँ पे, और विल बी H2SO3, फाइन। नाउ H2SO3 का कॉन्जुगेट बेस ये होगा, तो इसका कॉन्जुगेट एसिड ये होगा, ओके। नाउ कॉन्जुगेट बेस क्या होगा HSO3- में, H रिमूव कर दो और एक इलेक्ट्रॉन भी ज्यादा होना चाहिए, तो SO3 2-। ना NH3 के केस में अगेन यू शुड हैव 1 एक्स्ट्रा, ये तो पहली वाली इक्वेशन में भी था, NH4+, इलेक्ट्रॉन डेफिशिएंट आर ऑलवेज प्लस चार्ज। देन NH3 से यहाँ पे हमें क्या चाहिए, एक हाइड्रोजन रिमूव होना चाहिए और नेगेटिव चार्ज NH2-। HPO4 2-, H2PO4 1-, एक इलेक्ट्रॉन एक्सेप्ट कर लिया है। अब ये एसिड है, तो ये एसिड क्या करेगा, एक इलेक्ट्रॉन और एक्सेप्ट करेगा, इलेक्ट्रॉन एक्सेप्ट करेगा तो 2- हो जाएगा, सो दिस बिकम्स इट्स कॉन्जुगेट बेस, एंड एक H+ भी रिमूव कर देगा, ऑलरेडी 2 H थे, अभी सिर्फ एक H है, सो दिस बिकम्स द कॉन्जुगेट बेस ऑफ दिस एसिड। तो इसके लिए ये क्या होगा, कॉन्जुगेट एसिड। उल्टा CB यहाँ पे क्या होगा, H रिमूव कर दो, सो यू विल हैव PO4 एंड देयर विल बी 1 एक्स्ट्रा इलेक्ट्रॉन, 2- से ज्यादा तो 3-। SO4 2- में यहाँ पे क्या होगा, 1H SO, और ये एक माइनस न्यूट्रलाइज हो जाएगा क्योंकि एक H आ गया है, तो HSO4-। एंड नीचे क्या होगा, क्योंकि इसमें से हाइड्रोजन निकालने के लिए है ही नहीं, सो देयर विल बी नो CB फॉर दिस आयन, ओके। ये एसिड है अगर, तो ये उसका कॉन्जुगेट बेस है, और अगर ये बेस है तो ये उसका कॉन्जुगेट एसिड है, ओके, ऑपोजिट। लास्टली दिस वन ClO4-। अब इसका एसिड कौन होगा, जिसने ये ClO4- बेस दिया है, कॉन्जुगेट बेस दिया है, HClO, that's it, hypochlorous acid, okay. Now this becomes conjugate acid of this base, but for this acid this is conjugate base, okay. अब इसका conjugate base क्या बनेगा, एक H+ रिमूव करना है, H+ है ही नहीं रिमूव करने के लिए, so there will be again no CD, but what if it is made with H2O, तो conjugate base क्या हो जाएगा, OH-, ओके, क्योंकि वाटर का H+ ले लिया है उसने और बचा क्या, OH।